on, we'll have some design consideration that what all things can be included as part of this particular system design. Then we will have a high level architecture, we'll talk about the APIs, and finally we will talk about the payment processor. So this is going to be the content for this particular video, and there is a timeline given for each of these content, so you can move ahead and go back in the video using that timeline. So let's look at the terms to note. So the first term is the payment gateway itself. What is the payment gateway? So it is a service which allows us to make an online payment. So you can integrate it with an e-commerce website, and it will support the seller to basically collect payment in various ways from the user. So user can buy item and pay using a credit card, a debit card, internet banking, e-wallet, gift card, all those things. So everything will be supported by the payment gateway. Next thing is a payment service provider. So what is the PSP? So PSP is the person or is the system or the service which makes sure that money is transferred from buyer's account to the merchant account. So this will be integrated as part of the payment gateway itself. Issuer bank. Issuer bank is the bank which is related to the buyer. So this is the bank which has issued the debit card or the credit card or the UPI to the user so that they can go and buy stuff online. Card association. Card association is another entity. So this is the association which basically provides the number for your credit card and debit card. So these are organizations like Visa, Mastercard, American Express, all those stuff. Next is the PCI DSS, which is Payment Card Industry Data Security Standard. So what this standard means is that it is basically a compliance. And why this compliance is used? This compliance is used if you want to store a secure data which is related to your card. So if you want to store the card number, the expiry date, and the name of the person for whom the card has been issued, if you want to store that into your database, you need to be compliant with this standard. So all the payment gateways should be compliant with this PCI DSS standard. Other than payment gateway, even e-commerce site like Amazon, Flipkart, they are compliant with this standard, and that is why they are able to save your card on their website itself, so that you don't have to enter the details every time when you make payment. Next is the acquiring bank. So acquiring bank is the bank which is associated to the seller side. So you can think of the acquiring bank as a e-POS machine. So when there was not an online payment, or now also when you go to a shop and you want to buy some stuff using a card, so you will basically give the card and the seller will use a POS machine. So that POS machine is issued by some bank. So similar to that, the payment processor is also issued by some bank, so that you can consider it as an e-POS. So that is the acquiring bank. So acquiring bank comes into picture on the seller side. Now 3D Secure, so this is a protocol which was initially defined by Visa and now it is used by all the other card association, and it is used for added security. We will talk about it in detail in the section where we talk about how you make a 3D Secure card payment. And finally ISO 8583. So this, what is ISO 8583? So this is a switch message format. So when you come to payment industry and you want to make some payment, so a normal JSON message or XML will not work. All the payment messages are done in a ISO standard way, standard format way. So this is nothing but a message format which is defined by which is defined in the payment industry, and you need to basically, whenever you make a card payment, you need to send the message to other party in this format itself. It will not support JSON, it will not support XML. So these are few terms that will be used throughout this particular video. Next is we'll talk about how the card payment works. So for card payment, there will be a UI where your details will be captured. So this UI can be on the seller side or like Amazon or Flipkart, or it can be on the payment gateway side. So payment gateway also can expose a UI if the e-commerce website is not PCI DSS compliant. So in that particular case, in the payment gateways UI, you will enter all your card detail. Once the card detail is entered over SSL, this is sent to merchant's application. So this is the case where your merchant is integrated with payment gateway, And merchant application will also have a unit or a service which will be used for payment processing. So it will not do much, it will just capture those detail, and in a secured way it will transfer it to the payment gateway. Now over SSL this is sent to payment gateway. What payment gateway now will do is, like we talked about, all these messages will be in XML, JSON, or the format which merchant application understand or the payment gateway understand, or whatever merchant has decided to use the format for their application. But that does not work in the payment industry. So going forward from payment gateway side, it will convert that XML or JSON, whatever message format it is there, into ISO 8583 standard, which we talked about before, which is the one which is understood by the EFT switches. So this will be sent to a payment processor. Now payment processor is used by merchants acquiring bank. In most cases, payment gateway and payment processor will be used together. There are some cases where payment processor is separate from payment gateway. But in this scenario, we'll say that there are two entities. One is payment gateway, one is payment processor. Now payment processor, what it will do is, this will receive the EFT switch message. So it understand that, okay, I need to make a payment using the card transaction. So what it will do is, it will send the message to the card association. So card association are the entity like Visa, Mastercard, MX, and what they will do is, they will receive this message, and they know that which particular card number is associated with which bank. So suppose you have a card number like 426345550, something like this. So card association has a directory, and there they know that which set of number has been issued to which bank. So they know, suppose you get the number like 42365543, so they know that this has been given to HDFC bank. So what they will do is, they will redirect the request to the issuer bank, which is the HDFC bank. So card association will make the call to the issuer bank, or it will not make, it will redirect the message that it has got to the correct issuer bank. Now issuer bank, it will make the transaction, or it will verify the transaction, whether the card is valid or not, whether it belongs to the correct user, whether the CVV given is right, whether the PIN given is right. All those authorization will happen, and then it will check whether there is a balance in the account for the given payment or not. So if everything is successful, then issuer bank will authorize the payment, and it will deduct the balance, and it will send a message back to card association saying that, okay, I have received the payment and the transaction is good. And then card association will go back to payment processor, go back to payment, and finally the sale will be done. So this is the overall picture of how the payment happens. Now at any point, if there is a failure, suppose it fails here or it fails here, then the same has to be handled by payment gateway using payment processor. So we'll talk about all those things also in the coming part of the video. Now we'll move on to how a 3D secure card payments work. So what is the difference between a normal payment and a 3D secure card payment? So for the 3D secure payment part, till here everything is same, till payment gateway everything is same. Now 3D means that there are three domains involved. So what are these domains? So the first domain that will come into picture is the acquiring domain, which is on the payment processor side with the basically with the acquiring bank. So this is nothing but a small plugin which will be given by the acquiring bank, and this domain comes with a small piece of software, and that software is used for encrypting the message and decrypting the message also. So all those we'll talk about how all those works in the coming session. So what you need to understand here is that once the payment gateway receives the ISO 8583 message, what acquiring domain will do is, it will now convert it into a secured message. It will encrypt it, or whatever is the logic that has been written for that particular piece of software. So it will do its job, and finally it will send the message to the card association. So here the seller domain will send the card detail and to the interportability domain. So what interportability domain is that? On the card association side, we have an interportability domain, which is nothing but a set of directory. So what it does is, it will make a check there that whether actually a issuing bank is existing for the given transaction or not. So it will have a directory from where it will check, and if the card is fake or it is not valid, not valid in the sense that maybe it has expired, so in those situations it will not even go further. It will basically come out from here only saying that the card is not valid and the transaction has failed. So that is the use of interpretability domain. Now, if the card is a valid one, then in that particular case, this interpretability domain will send a response back to the acquiring domain saying that it is success, and it will give you a URL which will be for your access control server. Now, access control server is the server which is on the issuing bank side. Issuing bank is the bank which has given you the card. Now, if the card was valid, then interpretability domain will have the URL of the relevant access control server. So it will give that server detail and the URL to the acquiring bank, and now the payment processor can make the request to the issuer with this access control server link, and it can send or receive the secure message. Now this secure message is whatever the encryption logic has been used by the acquiring domain, and it will send the actual request, which is the card detail with CVV, PIN, everything, to the issuer bank. And here in the access control server side, again there is a piece of software which is running which can decode this message, and it will do the authorization. So once the authorization is done, everything is checked here, and if the payment is successful in that case, or even if the payment is failure, in that case it will be sent back to the processor with a code, and that code will tell us what is the reason for failure, or if it is a success, then the transaction is success. Now from here the same request will follow. It will go to payment gateway, and if the payment is success, then the same will be displayed, that order will be placed in merchant's application. Otherwise, a failure message will be shown that the payment has failed and what is the reason for failure. Now in this whole scenario, this whatever is given in the yellow bordered line or the box, this is the actual payment gateway. So this payment gateway that is written here is that it's the UI ingestion part, and I have just shown for explanation purpose that payment processor is a separate entity, but it can be integrated as part of the payment gateway itself. Now, if you are clear on this part, we'll jump into the requirement and quickly look into the system design for payment gateway. So first we have the functional requirement. The first requirement is that it should allow multiple ways of payment. What it means is that it should allow card payment, it should allow UPI payment, it should allow internet banking payment, maybe gift cards and all those things. Then all the payment details should be secured. Your transactions should be secured. It should avoid double payment in case of failure or retry. It should not happen that the issuer is charged twice or the buyer is charged twice, which will be a very bad thing. The response should be fast. So all this process that is taking place, it should happen in like a matter of seconds. And the payment gateway should handle the timeout and failure. So it should have some mechanism of retry if the transaction is timed out or if it's failed in between. And on the non-functional side, the system should be highly consistent, it should be highly available, and it should be highly scalable. So we are okay to give away the partition tolerance. So we cannot give away consistency. It cannot be like the system is eventually consistent. Here we want a hard consistency. System should always be available. Why it should be always available? Because if it is not available, there will be failure in transaction in between and no one is going to use it. And it should be scalable because going forward, if it is a success, then more people will come and use it. Now we'll look at some of the design consideration for this particular system. So what all things we should consider? First is the multiple subsystems to handle different kind of payment. You should not burden one module of your application to handle all the payment. You should have like small service to handle a simple or a simple transaction or a simple payment type, like one service to handle or one API to handle your card payment, another API to handle internet banking and UPI, because all these three are not related. So different types of payment will follow a different procedure, and that is why it should all be decoupled. Next is secure your payment detail. Now since as part of your payment you are going to store the data or store the transaction in your database, so that is why it's required that you secure the payment detail. So if there are some PII which will be there, like the card detail, the account detail and the seller detail, So all these details should be encrypted. You can use any tool for that purpose. Now, whenever you are sending the transaction, you should use SSL. In this particular scenario, you cannot send it in a plain text way. Now here, consistency and availability should be chosen over partition tolerance. And like I told that, it's okay, we don't want multiple copy of the transaction, but the transaction should be consistent and it should be highly available. And there should be some way in which if there is a failure, we should be able to handle that and avoid the duplicate payment or the loss of money for the buyer or the seller. So that is why we need to save that transaction. Now to achieve that, we need to save that transaction, and that is why point number 2 is also there, that since we are saving these details, we should encrypt the PII fields. Next is that the system should be scalable, because we will handle like 10 million kind of transaction in a day. So let's look at the high level architecture for this design. So we have a seller's website. From seller website, we will get the detail, or the seller, either seller will send the card detail to us directly, or it will send the request to payment gateway to expose the UI to the buyer so that they can enter the card detail there. It can be in two ways, one of the two ways. So once we have exposed the UI or the seller has sent the detail to us, what we need is we need an ingestion system where we need to ingest the payment that is coming through. So we'll get the payment. This what payment ingestion service will do is it will ingest the transaction. It will save the transaction in our database. Now to save this transaction, we need a transaction ID generator. What this transaction ID generator will do is it will create a unique ID which will be associated to this particular payment. Now since it is associated to this particular payment, anytime we have to retry or some failure happens or we need to debug, so we can use this ID to track this whole payment, because in our scenario we'll send the request to outside, and from outside we'll get the response. Outside means if it is a card transaction, we are making a call to the card association, we are making a call to the control access control server also of the issuer bank. So everywhere this transaction ID should be used for tracking of this transaction in an atomic way. So once we have the transaction ID generator, we will save the detail in our database. So database, how we will save the detail? We will save the transaction ID and the other payment detail. Now the other payment detail comprises of the type of payment that we are getting from seller's website, whether it is a card payment or internet banking payment or UPI payment. So the second column can be, first column is your transaction ID, second column can be your type of payment. Then you will have another column which will store the ID of that payment type. So if it is a card payment, you need to store the card number. If it is internet banking, then you might need to store the internet banking user ID. If it is UPI payment, you need to store the UPI ID. So one column will be for that. Then another column you need to save the your amount. What is the amount of this particular transaction? Then you need to store this transaction belongs to which merchant. Basically, when clearing happens, which merchant bank or which merchant account should be credited with the payment. So that detail will be required. Now when we consider all these scenario, we see that the data that we are getting is very structured. So RDBMS will be a good choice for this database. We can also have another database which will pull the data from here and store for analytics purpose. We'll talk about it in later section. So once we have stored the data in our database, we'll put that message in a distributed queue, because we want to decouple the ingestion system from the processing system. So we have the distributed queue, we put the message there, and then the processing system will pick up the message from the distributed queue and it will do its processing part. We'll talk about the processor or the design of the processor in the later section, and we'll see how it will be talking to the queue and to the database. So finally, in a very good scenario, once the payment is done, it is successful, or if it fails, payment processor will update the database for this transaction ID saying that okay, the transaction has been successful or failed. Now one more thing before going forward, that how you will make sure that the query on this database is very fast. Now you have chosen RDBMS for this, so you need a partition strategy or some way in which you can basically speed up the query, because you will be getting so many queries every second. So one good way will be that you partition all your table based on date. So every day will have one partition. Now you can create a sub partition for your RDBMS. That sub partition can be based on the type of the transaction. So there will be one sub partition for the day for UPI payment, one sub partition for the day for your card payment, and so on and so forth. So those can be list partition, date can be a range partition. So that will be a good strategy, so that when you query, you will be basically pruning the partition and picking up the data from the individual partition. So if you don't have the knowledge about partition pruning and all, don't worry, we'll discuss it in some other video when we talk about the database partitioning and all those strategy. You can just have a look on the Google, and you will understand. Partition pruning is basically when you pick up the data from an individual partition rather than scanning all the partition of the table. So that will be a good thing for all the queries, and you will get a efficient query mechanism here. So this is overall architecture of the payment ingestion. I have not talked about payment processor also, because we will break down this payment processor system into smaller component going forward. Before going to that, we'll talk about some of the APIs which will be relevant to payment ingestion and payment processing. And sorry, before that, there is an analytics service also. So why we need an analytics system here is that it can talk to the queue, and it can also pull some data from this database. Or a better way will be that there can be a service, a separate service, which will pull the data from this database, not required in a real time, in a non-real time system also. And what it will do is it can put it in some other database, which can be RDBMS, or it can be a NoSQL database also. A NoSQL columnar database can be a good choice if you want to perform analytics like handling the failure scenario. So if you pull all the detail from this database where there was a failure for a particular type of card transaction or a internet banking transaction, so what you can do is the analytics system can compute a stats that, okay, if the transaction was coming from Visa card, X percentage of transaction failed today. If it was coming from a UPI payment, Y percentage of transaction failed today. Now these analytics can be sold to the seller, which is Amazon or Flipkart, where what they can do is they can showcase the same data to the user during payment time, and they can say that, okay, whenever someone has made a payment in past 1 day or 2 day with using this Visa card, the failure percentage was this much. For UPI it was this much, for internet banking it was this much. So that can basically help the user to, or the buyer, to take a informed decision that, okay, do I want to make a card transaction or shall I make an internet banking transaction. So that is where the analytics will come into picture. That is one part of the analytics. So if you want to do that, a columnar database can be very helpful, because it will have you can have similar kind of column families there. For one family can be for internet banking, one family can be for your card payment and all those things. So next, look at the relevant APIs that is present. So for payment ingestion, the first API will be you get the form for card payment. So if the seller website is PCI DSS compliant, in that case they will send a request to payment gateway, and they will say that I want the detail. If the payment if the seller's website is not PCI DSS compliant, in that case they will send a request to payment gateway saying that I want a form for the card payment. So card payment form, this API can expose a UI to seller's website, so there they can show a form which will have the data to be filled to capture the card detail, expiry date, CVV, name, all those things. Once we got those details, you need to post the request for the card payment. So what this API will do is it will start the ingestion for card payment, it will store it in the database, and finally it will put the request in the distributed queue also. Similar to this we will have for UPI, for internet banking, and for if someone wants to query a transaction based on transaction type, so you get the transaction ID and all those details using the transaction type. This can be helpful in case of building of the history of your transaction. There can be one more API to get the history of transaction for a particular user or a particular transaction type for seller also. So those can be discussed with your interviewer, or if you're building up your system, then you can come up with all those requirements and add those APIs as well. Now for payment processor, the first will be you process the UPI payment. So this can be a simple microservice. Similar to that, you can have a process for card payment, for internet banking payment. Then you can have a service or retry on failure. What happens when there is a failure in any one of these transactions? And finally, you get the ISO message for your given XML or JSON message. So all those things will be there as part of your payment gateway, and these are the relevant APIs. Now we'll talk about the payment processor in more detail. So we'll break down the payment processor. So we know that once we have put the message from the ingestion service into distributed queue, from here it will be picked up by the payment processing service. So what payment processing service will do is, as you remember in the diagram where I showed that how 3D secure payment work, it will have a plugin, and this particular plugin will send the request to the plugin for acquiring domain. It will send the request to the interpretability domain, and from there it will get the URL for the access control server. So all those piece of code will go here. So it will have all those modules to do the payment, and finally once the payment is done, then it will update the status, or it will update the status of the payment in the database. And in case of failure, what it will do is it will put the message in a, it can be the same distributed queue, or but the topic will be different basically. So it can put the message in a failed queue. So it can be the same queue that we are using if you are using Kafka or any other distributed queue. So you create a new topic for just dumping the failed messages. So once the failure is done, you update the message, you update the status in database saying that this payment has failed, and put the message in the queue saying that this is the transaction which has failed. Now why this queue will be helpful is because there will be another service which will be your payment retry service, which will be listening to this particular queue, and it will what it will do is it will check for that transaction, that what is the status. If it has failed, then it will retry that particular payment. And since the transaction ID is unique, so when it makes a request to the card association or issuer bank with the same transaction ID, it will get a status from them that this payment was already processed. So if it was already processed and it failed in between in that particular system, this payment retry service will update the database simply saying that the payment has been successful. It will not duplicate the payment. So that is the benefit of this retry. And finally we'll have a clearing service. So once all the payment is done, so till now whatever we were talking about was from the buyer's point of view. Now when the buyer's point of view is, immediately the money was deducted from buyer's bank and it was parked somewhere. Now from this somewhere's account, or in some account, it has to go to the account of seller. Otherwise there will be no point of seller doing the business, right? So this clearing service, it will read the database and it will pick up all the successful transaction, and in the database also it will be, there will be a, we can add one more column which will say that the transaction has been cleared or not cleared. So it will pick up all the transaction for that day which is not cleared. So this clearing will happen like once in a day at end of day, or it can happen like twice in a day, whatever is the relevant period that has been fixed. So what this clearing process will do is it will pick up all the transactions that are not cleared yet, and it will settle the account. So if suppose seller 1, there were 10 users who bought the product from seller 1. So whatever is the amount that the seller 1 has to send, or whatever is the amount that seller 1 will get after deducting of course the charge for the payment processing and the e-commerce side, the same will be credited into their account. So that part of handling will again be done by clearing service. So clearing service will again follow the same procedure which we were using for card transaction, only this time it will use the internet banking facility or the clearing House facility, so that is another complex topic to discuss, but at high level you can understand that uh, initially when the money was deducted from the buyer's account, it was parked into the account which was owned by acquiring bank of the seller or the merchant basically, which in this case is Amazon. Now when clearing happens, the money will be deducted from the acquiring bank's account and it will be sent to each of the individual seller. So that is where the payment clearing service will come into picture, and it will be part of the payment gateway itself. And if this transaction has failed, the same logic will apply. It will put the message in the failed queue and a retry will happen. Now again, for the clearing service, I missed one box here, which will be a transaction ID will be generated for clearing. So this transaction ID will basically map all the transaction that happened for that seller on that particular day, or whatever is the clearing time, so for that particular clearing time. So this is the overall picture of your payment processor, and this will be integrated with the payment ingestion, and overall it makes up the payment gateway. So I hope the explanation was very clear. If you have any doubt, put it in the comment section, and if you have reached here, do like the video, do subscribe to the channel. So thank you for watching this particular video. See you in the next video. Take care. Bye.